What's up, guys? So I've got a three-star puzzle by Flinty and Palpot, and it's Palpot. It's called Dutch Flatmates Coordinate Arrows. Let's have a look at the rules here. Normal Sudoku rules apply. Place the digits 1 to 9 so that they do not repeat in any row, column, or 3 by 3 box. Dutch flats. Okay, I've also heard it called Dutch Flatmates, as it mentions up here. Every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need to have both. Now here's the interesting rule. Coordinate arrows. Digits on an arrow spell out the coordinates for the digit that is their sum. The row number is written on the start of the arrow. The column number is written on the arrow tip. All the arrows must correspond to different coordinates. Okay, so no two arrows are going to be the same pair of numbers. Digits may repeat on an arrow if allowed by other rules. Example, okay, 1 and 4. Then row 1, column 4 must be a 5, which is 4 plus 1. Okay. Makes sense. Let's get going. Okay. So the most interesting things might be this feature and this feature. And I think, let's look at this one. Excuse me, and think about what this means. So whatever's in here so the first thing is that we have to make sure this number is not too high. And actually, yeah, well, yeah, you can have any number on on an arrow except a 9. Okay, that's clear. So actually, this could be pretty high. I guess the highest it can be is 6, right? Because of course the sum can't be greater than 9 of the two digits. So the highest this can be is a 6. And these obviously don't have to be, well, if it was a 6, they do have to be in a sequence. But if this was a 2, then this could be a 5, could be a 7, could be a 1. And then everything is going to be in row 2 in that case. And then I'd be looking at this spot, and this spot. But right, I mean, that makes sense. Then we would have a 3, a 7, and a 9 up there. Okay. How else can I constrain this? So this is all going to point to the same row. The sums all have to be different, which they will. I mean, that will happen just by virtue of normal Sudoku rules because they're all in the same box. And then the sums will appear in that row. So if this was a 5 and a 6, I suppose it gets a bit interesting because then, well, actually, I suppose 4 is also interesting because then it starts to appear in the same box that the coordinates are in. But I don't think that's a problem. 6, 1, 2, 3 means we'll end up with something here. And this will Yes. So we'll end up with this with a 6 and a 2, which is going to give us an 8 over here, which means that this would have to be a 1. So then we'd end up with 2 and 1. And what would this be? This is kind of interesting. Sorry, did I say 2? I meant an 8 and a 1. So then we have a 9 there. Column 1, something is being placed. I mean, I don't see why that's a problem. What's this? 5, 5. So, if the sum were to appear as 9, 6, 1, 6. I mean, the other point is that all 4 of these are from the digits 1 through 6. There's no digit that's above 6 in that square. Okay, but that's interesting because so this is a 9 because all of these are on arrows, and you can never have a 9 and an arrow. So we end up with a 9 right there. Okay. I'm trying to understand what's special here. 2, 2, 5. 5, 1, row 5, column 1, row 5, column 6. I mean, that's not going to work. Let's say 3 and 6 puts a 9 there. There's no problem with that. We just need to be careful of our usage of the numbers 1 through 6 over here. And now with a 9 there, we can't have another 9 in this box or this, or column 6 column 5 or row 6. Row 7, column 5, row 7. So we can't have an arrow that sums to a 9 where the row digit is a 7 or the column digit is a 5 or the box, right? But the box is never going to happen because the lowest that you would need is a 7 and a 4. And then this would have to be 11, which is not possible. So none of our arrows can actually reference anything in these boxes. And actually our arrows can probably only reference things up to... No, this can be referenced. No, that can't be referenced. This is it, yeah. So this is the no-go zone for our coordinates. Does that mean anything significant? I don't think so, but it is interesting how many arrows are within the no-go zone. But I guess that kind of makes sense, right? Because the arrows are never going to point to themselves, because both of the digits on the arrows are always going to be less than the sum, obviously. And there's no reason why that has to be a 9, right? Just a weird question. Just based on the fact that it's kind of a special cell. But no, there's no reason why that has to be a 9. Only if we have an 8-1 arrow somewhere. And we're not going to have an 8-1 arrow there. 8-1. So let's think more about box 8, because we have these 4 sums. And there's kind of intuition or like spidey sense that's saying maybe they all add up to 9, but there's... Actually, is that... I think that is actually true, because if one of them doesn't add up to 9, it means you've used, for example, it means you've used 2 low digits for a single sum, like a 2 and a 3. But now, I only have 2 other low digits. So I've got one sum, another sum, and a third sum that each have at least 1 low digit. But now I have a 4th sum where both of the digits are high digits, where high is at least a 5. So yeah, I guess high and low is not a great way to think about it, but this obviously doesn't work. So all of these is going to be a high and a low digit with 4 distinct sums, which is part of the rules, right? I know it's in the rules, but let's just find it. All arrows must correspond to different coordinates. So each of these is going to add up to 9, which means we're going to have an 8 and 1, but it's not necessarily here. It could be 8-1, where 1 is at the point, or it could be 1-8. But one of those is a 9. Oh, and this is actually a no-go zone as well, I just realized. Wait a second. Oh, wait a second. Our no-go zone goes through here, obviously. All of that is off limits. Of course, it's symmetrical over the diagonal. So one of those is a 9. And then this one becomes the only digit on an arrow that's not within the no-go zone. So each of these have to form a 9. Okay, so I'm going to start marking. It's just a bit. It's a bit sketchy. Oh my gosh. Wait, if the digits sum to 9, it means it's on the diagonal. This is 5, 4, and 4, 5. 9 can't go there. So one of them has to be 5 on the whatever you call that, and 4 on the tip. And that's a 9. And then we have 9s. Well, 9 can't go there, so that has to be a 9. And that's quite interesting. And I've completely forgot about the Dutch flatmates rule, by the way. I actually completely forgot about the Dutch flatmates rule, which does involve 9s. But I don't know if it's particularly useful just yet. It means I can't put a 9 there, which means that is a 9 over there. And then we just don't know about this. One of those is a 9. And we just don't know how these digits are going to play out. We just know the orientation of each of the sums, but we don't know where the sums themselves are. Like which of the sums appear on which arrow. But we've learnt a lot about the orientation of the sum. Sorry, those two. One of those is going to have a 9. Interesting. Well, there's definitely a 9 in one of those cells. We can play a bit of Sudoku, I guess, if we really must. I mean, yeah, we don't know a whole lot, to be perfectly honest. But making some progress. And this enables 5s to be in these locations. This can still be a 5. So these then are taken from the digits 1, 2, 3, and 4. But if this was a 5, it means the digits... Wait a second. Wait a second. But I can't make a 9. So I can't have 5 and 4, which means I would have to have 1, 2, and 3. And then this would be 6, 7, and 8. And this can't be 6 now. At least we know that, because the 6 will have to create a 9. But I don't see any reason why it has to be the 5. I really wish I could demonstrate why it has to be a 5, because then we get a lot of information. But it doesn't work like that, unfortunately. You know, if this is a 1, there's obviously a lot of possibilities for these. Everything from 2 through to 7. Sorry, not 7. Yes, to 7. Dutch flatmates. What I need is 5s, not 9s. Now, what about this? Does this not tell us something interesting? So this is creating a weird structure, right? So I'm selecting a row, I'm going to a column, and then I'm reflecting. So if I'm in column 6, I'm then reflecting down to row 6. Yeah, I mean, it's not really a reflection. I don't know what you would call that, but I go from column 6 into then row 6, and then I pick a column, which could be any column over here. And then from that column, I'm then, you know, say it was column 3, then I'm going into the row 3, and then I'm picking a column. These digits all have to be different. This one doesn't. I don't know what to say about that. This random arrow over here. I mean, what? Fives. Maybe we can think about Dutch flatmate in box 7. So yeah, so we need a 5 somewhere here, but 5 is never going to have a 9 below it or a 1 above it. Oh, that's actually not very helpful. It means I can still put a 5 anyway here because I can have a 1 above it. If this was a 1, then I would know that I can't put 5s down here, but we don't know that. So the 5 can go anywhere, but if the 5 is here, ooh, we do actually get some very good information. The 5 actually can't go, well, it can't go there for sure, because this would have to be a 1, but that doesn't add up to 9. It can't go there for the same reason. It can't go there. But one Oh, give me a second. These are spots. These are spots for our fives. But if the five, what did we have here? We can't put a 5 there or there. Or there, actually, right? Because those are all columns. But we don't... We don't reference column 5. We reference row 5. And column 4. So one of these is the 5, but if this is the 5, then that's a 1. But we don't reference row 1. We reference column 1. So that's the 5 and that's the 1. I'm very positive. That's the 4. That is not a 1, which is good, because 1 is the least constrained. So I'm happy with that result. And now, where would we put 5 here? Well, we could put it there, but we've used... those are the only spots for 5s. If that was a 5, that would have to be a 1. If that was a 5, that would have to be a 1. Which, unfortunately, is perfectly permissible. But we don't have 5s anywhere there. Oh. Sudoku, duh. So either one of these is a 1 or that's a 5. There's got to be something I can use here. Come on. No 5s. 4. Shoot. Can I do anything with 5s in this box? Well, I can't put 5s there. 5. Can't put 5 there. I could put a 5 there. If I put a 5 here, I would need 1s over there. 5 1s. Column 1. I can't put a 5 there because I would need row 1. No, these don't add up to 9 though. These don't add up to 9. Relax. I don't know. I think all of these are legitimate. These ones add up to 9, not these ones. Wait, but again, I missed Sudoku. There's no 5s there. There's no 5 there. One of these is a 5. 5 1. 5 1. And one of these is a 1. This is terrible pencil marking. Really terrible pencil marking. But yeah, I don't think I can figure this out. I don't see anything. I don't see what can help me there. We have an 8-1. It's not that one. And then we have a 6 and a 3. What was our 6 and our 3? Oh, was this the one? This was the one we didn't figure out yet. That's the one we didn't figure out. So, but we need an 8 and a 1 like this, and then we need a 5 and a 4, and we need a row 2 column 7. Row 2 column 7. Don't know anything about that. Don't know anything about that. Not going to bother with that one. Come on, we have to get something here. Row 2 column 7. I need a row 2. Oh, hang on, this is helping. Because I've just eliminated 8 and 2 from this. 8. Well, 8 wouldn't have been in there anyway. But I've eliminated... No, what have I done? I haven't eliminated 2. No, sorry, I got confused for a second. A 2 and a 7. 5, 3, 2... 3, 4, 5. And this can still be a 5, right? 5, 2, 3, 4. Wait, how can this be a 5? This can't be a 5 anymore. Because we've already done the 5, 4 coordinate, and we can't use a 1. 4, this would be fully constrained to being 2, 3, and 5. But if one of these was a 5, we would end up with a 9 there, which we can't do. So that can't actually be 4 either. And then if it was 3, I'm sure it can be 3. 2, 3, 4, 5. 3, 6. Yeah, we didn't know that was the thing. But yeah, we have 2, 3, 4. Two, 3. 2 would be 3, 4, 5, 6, 7, and 8. Ooh. Can't do 8. Can't do 3 and 5. But to my knowledge, until we disambiguate these 9s, we can do 3 and 6. 3 and 6, so we just can't do... No, sorry, I made a mistake. It starts with 5, 6, 7. What am I... Wait, I'm confusing myself. With a 3, I can't do 1 because it's taken. I can do 2. It starts with a 5 over here. 6, 7, 8, and 9. That's how it works. And all of those are valid. And then 2, we have all of that plus some other stuff. There can be a 2 or a 3. So one of these is a 5, which means one of these is a 1. Would love to get something here. Would really love to get something. Fives in box 2 are actually kind of actually very constrained. They're over here. Hang on. But then this has to be a 9. Oh my gosh, did I just figure this out? Wait, let me double check what I was thinking of. So there's no 5s there, obviously, because it's Sudoku, and Dutch flatmates it would cause issues. So these are available for 5s. Now in this column, if I have a 9 below it, well, it's not going to have a 9. So I think this was my thinking. I can't put either of these because they'll never have anything above it, and they can't have a 9 below because there's a 9 there. And then these two, well, they can't have a 1 above it because we know one of these is going to be a 1. Or they can't have 9s below it because there's a 9 there. So 5 has to go there. But if 5 has to go here, wait, could 5... No. 5 can't go here because there's no 1 above it, there's no 9 below it. So this is a 5. And that's a 9, and that's a 1, and that's a 5. And that's huge. That's absolutely huge. There's disambiguates that, gets those out of the picture, gets those 5s out. 5s are there, 1s are there. That 9 is out. We need a 3-6. Like that. Okay, and I'm pretty sure we're going to figure out this now because this is very constrained. So if this was a 3, well, I can't use a 2 anymore. It doesn't work. I can't. So I'm looking at this row, right? We only have 4 slots available, but I can only start with a I can't put a 1, I can't put a 2 because we have a 2-3 pair and we have a 1 in the column. So I only have 2 slots, but I need to put 3. So that's a 2, that's a 3, that's our 6, that's our 2, that's our 7. One, 2, 3, 4. That's all of our 9s. And now this, I think, is going to be these. No, 2, 2. It's these. 3, 4, and 5. giving... Ooh. Mistake. Because I can't put a 3. Because that'll sum to 5. Oh dear. Oh dear. I think it must have been this Dutch flatmate that I messed up. Let's have a look. I'm just gonna figure out. Okay. I'm enjoying the puzzle. I want to keep going. We're going to reset to here where the solution is correct at this point. So I made a mistake here. I'm going to think about this again. So let's assume my pencil marks could be wrong, right? Let's assume my pencil marks could be wrong. So what are our options for this? I'm going to rethink this completely. So 2, 3, 4, let's just say. 5, once I get to 6, obviously can't be 7. 6 would be 7, 8, 9. 6, 1, sorry, what am I saying? 6 would be 1, 2, and 3, but we can't use a 1. I'm very curious what mistake I made here. 6, the highest the sum can be is 9. Let's just check our kind of first principles. So I can only ever use 1, 2, and 3, but 1 is taken, so I can't do anything. So it's not 6. If it was 4, I'm placing digits in this column. Ooh, can it be 4? But one of these has to be a 9, which means I'd have to do 4 and 5, but I can't use 5. I feel like I'm converging on the same answers, so I need to figure out where I went wrong. And let's just double check everything. So if that's a 4, we're looking at this row, right? I can't put a 1. I can put a 2, giving me 6 here. Then I can put a 3, giving me 7 over here. But one of these has to be a 9. And why do one of these have to be a 9? Why do one of those have to be a 9? Obviously, those can't be 9s. And that can't be a 9. But why can't this be a 9? Oh. Because... Oh, but... that can be a 9. Ah. I made an error in thinking that 9 there and 9 there were mutually exclusive, but there's actually no reason to think that. I just knew one of them had to be a 9. So that can be a 9, and perhaps indeed it is a 9. And so 4 actually works, but now, so I guess then, because I'm guessing it's probably a 4, right? Because I made the error, but I'm going to continue the puzzle without knowing, without using that error to my advantage, right? So I'm not going to put that down as a 4. But let me just check the others. Well, actually, I guess I can say it's a 4 because I will discover that I can't put a 2. I can't do 2s over here. So I'm going to put 4 here, right? Because it's a 4. And the reason I know it's a 4 is because 3s don't work in terms of what can be fit in here, and because of the pair, and 2 didn't work because I need to end up with a 3. over there to occupy 3 cells without using the 2 from the pair and the 1 from the box. And that equals 5, which would conflict with that, so this is a 4. And with that being a 4, the 9s come out, that becomes a 9. No 9s there, 9 there, and looks like we get all of our 9s. So 4, 4, we're here, we're 2, 3, wait a second. I'm missing something. I've just missed something because I've made another error. 4 doesn't work either. Because I would do 2, 3, and 4. Shoot. 4, 2 giving me 6, 4, and 4 giving me 8, but I can't put 2 4s. Can't do 5, can't do 6. Ah, shoot, come on. What am I missing here? Does 2 really not work? Oh, man. So, for 2s, I might have to take a break in a second. My brain's getting a bit frazzled at this point. It's quite late here. So for 2s, I'm placing digits in this row. To make a 5, I would have to do 2 and 3. Yeah, this can never correspond to an arrow because it's in row 2, column 6. Actually, yeah, that would be... Well, yeah, then it would have to be an 8, right? So 2... I can't put another 2. I would do 3, 4, and 5. No, yeah, it doesn't work. I mean, so let's just think about it before we discount it. Okay, so it would be 2 and 3. I can't do. 2 and 4 giving 6. 2 and 5 I can't do. How is this possible? I just hit a roadblock every time. And 3. No, I think this is where I made the error. I said I can't do 3 and 2 because of the pair, but I can put a 2 over here. I think that was my error. So 3, 2, that becomes a 5. 3, 4 for a 7, and 3, 6, but Yeah, but these pencil marks are wrong because I wrote those pencil marks with this assumption about that this couldn't be a 9. But one of these is a 2 and one of these is a 7, but I don't know where the 6 and the 3 are. And it looks like this is going to have to actually reference that one. And then also I lose the pair, but that's fine. So I think that's what it is. I'm going to check 4 one last time. Well, I still have some energy. Yeah, these pencil marks I can kind of ignore. 4 and 2 gives me 6. 4 and 3 I get a 7. 4 and 4 I cannot do. And then 4 and 5 obviously would be a 9, which means that's about. So this is what's happening. This is a 3. These are 2, 4, and 6. And then this, so this references that 9. And then we have to create a 6, 3 like that. That can't be the 3, so that's going to be the 7. That's going to be the 3. Which means that that's the 2, and that's the 6, which blows the 2 out of here, making that a 2, and that's our 4, 6 pair. Okay, I mean, that was pretty cool. Okay, it was tough, but kind of really beautiful in a way. And then, so we've put in 3 and 2. So there's the 5. That is going to be the 7 we know already. Now you start to get a bit, wary of your pencil marks, but indeed I think this is pretty true. So 5 and something, it's not 5 and 4, it can be but we need this to be the 1, right, if that's the 5. So it's not there, so it's 5 and 2 to give 7, or 5 and 3 to give 8 over there. It's so interesting how these arrows dictate where the numbers end up. It's really beautiful. What do we have here? We've got 4 and we need an 8. 4 and 6 here we need 7 and an 8. 7 and 8 for 6. This should be known. That's a 3. And then this is 2 and 6. How are our 5s doing? They're all healthy, right? That's going to be 1 for our Dutch people. Cool. We'll definitely think about 5s very soon. Row 2 or row 3? Well, 1's out. No one's referencing this 9 yet, right? So that could be a 7. If it's a 2, can't... I mean... Ugh, I think there's a few possibilities. Those are out because they're too small. That one is referenced. I think there's a few possibilities. Should I really go through them all right now? Maybe I should. That's obviously the 5. Ooh. No 5, no 5, no 5. 5s with a 1 above. One of those is a 5 and one of those is a 1. Not enough to figure it out. 5s, there's no 1s above, so that's going to have to be the 5 to take the 9 below it. No 5s, no 5s. No 1 above or 9 below. That's going to have to be a 5. That's going to have to be a 1. 5 and 1 there. Cool. Nice. So we've done all of our 5s. They're all happy. They're all very happy. Good. So we have... So this, I don't think we can disambiguate. So either we can play some Sudoku or we can think more about these arrows. I might play Sudoku a little bit because I think this is going to give me a headache and it's pretty late and I feel like my brain is a bit exhausted right now. So let's play a little bit of Sudoku. Get some 1s. Don't fancy the 2s. Interesting. 7s. No, that's no good. Yeah. Okay, that was fun. So let's go back here. This is a 2 or a 3. Okay, if it is a 2, we're in this row. Can't put a 1. So we're for each cell, we're checking 2 things, right? We're checking if I can put the column coordinate there, and if I can put the sum over here, right? So I can't put the column coordinate in here. Can't put the column coordinate, and also can't put the sum over there. Here, I can put the column coordinate, but I can't put the sum because it would be a 5. Over here, yes, that can be a 4. This can be a 6. And that would be very nice. 2 obviously doesn't work. Wait a second. Oh my gosh. We've already used 3, 2. Because I think I had, if that's a 3, that has to be a 2, right? Because we can't do 3, 4 because it's already taken. So 3, 4 is taken and 3, 2 is taken. Oh gosh. Okay, it took me a long time to find that. Okay. So the 4, 4, the 2, 4, those are taken. 4 comes out, 2 comes out, 3, 7 pair, 6, 8, makes that a 4. Very nice. There's our 6, there's our 4. Can't be 2, has to be 3. Can't be 4, has to be 2. And we hit the 5. So what can this be? 1, 2, 3, 4, 5, 6. Maybe could be 6, I guess. Six. 1 for a 7. Can't be 6, 1. 6, 2, 3, 4, 5, 6. 6 not gonna work. Can that be 6? Huh. This is very puzzling. Was there any Sudoku that we could play? Huh. Okay, I don't think it can be a 2. 3. 3, 2 can't be. 3, 4 can't be. 3, 5 can't be. 3, 6 can't be. 3, 7 is too big. 4 can't be from Sudoku. 5, 6. Okay, so 7 from Sudoku. 8 would have to be a 1. Whoops. Okay, so it has to be a 6. 1, 2 doesn't work. 3, 4, 5. What am I missing here? Oh wait, did I? I think I skipped 2, 2, 3, 3. 3, 3. That's the one. I skipped. I skipped it for some reason when I was thinking about it, because I was thinking can't be repeated, but obviously can be. That's the one. Okay. Let's see if we can wrap this up. Threes. A 6 has to be there, so that becomes an 8. And that becomes a 6. Eight. So here. Let's look at these. 2, 3, 4, 5, 6, 7, 8. 2 and 8. And then over here we've got 6. 6, 2, and 8 as well. Three, 2, 8. Twos, threes, fours. And 8s. So we should be able to get this digit. 1, 2, 3, 4, 5, 6, 7. It's 7 over there. Unfortunately, doesn't give us 7 there. So here we've got 287. That's going to be a 2 or an 8. 2, 6, 8, 2, 4, 8. 2 and 4, 8 or 6. 3, 6. 7s. 7 can go in a few places there. We do have a 4 given. Ah, 2, 6, 8, 4 over there as well. Over there. Six, 7, 8, 6, 7s. These are going to be from. Oh, don't we know these? That's our 6. That's our 2. 6 is not there. 2 is not there. 2's there. What's this? Also 3 or 7. This is from 4, 7, and 8. No 4 there. 4, 7, 4, 7, 8. Here's 2, 3, 7, 8. No 7 there. 3, 7, 8 checks out. What are we missing? Let's just fill this one in. So I guess 2, 3, or 4. It's gotta be a bit careful. No, but the 8 is not there. Yikes, I'm not gonna... Yeah, those pencil marks are a bit chaotic. Four, 4 is the 8. 2, 4 is the 6. 5. There we go. I thought I must have been missing one. 6, 8, 2, 6, 8, 2, 8. 2, 8, 2, 6, 8, 6, 8, 6, 8. 8, 2, 4, 7, 3, 4, 8, 2, 8, 6, 8, 8, 2, 6. Nice, we got it in the end. Bit rocky.